which is the expression in front of the log. Log is a function that is only defined for positive values. So that means its domain is greater than 0. So when we solve for these equations, we always have to check our answer by plugging the answer into the argument, back into the log, to see if we get a positive value for the argument. So if not, if we're getting a negative value, that means we have an extraneous solution. There are some properties of log that we're going to use in this video. The first one is when we have log of something with base b plus log of something else with the same base, I can write them as one log and then multiply them together. So when I have log of x with base b and log of y with base b, notice that the bases are the same. I can rewrite this expression as one log and multiply the arguments together with the same base. But if they are getting subtracted by each other, I can rewrite it as log of x divided by y base b. Again, bases are the same. And if I have some number, some constant, getting multiplied by the log I can rewrite this as log of x to the a base b. So this coefficient here moved to here as the exponent of the argument. There's also a video on properties of log. You can watch that video to review. So I have the properties of logs here, the ones that we're going to use in this video. And here's our first example. So I have log of 2x equal to 10 is a common base for log. So when there's no base, we're going to assume that it's 10. So for example here, I didn't write that. I can just write that to show you. But if they don't give you the base, that means the base is 10. So when I have log of 2x equal 10 with the base, log of 2x equal 2 with the base 10, that means that 10 to the second power is equal to 2x. So I'm going to write that. 2x, which is the argument, is equal to 10, which is the base, to the second power, which is a number right here. So 2x is equal to 100. 10 squared is 100. And then I'm going to divide by 2, both sides. So I get x is equal to 50. So the problem was to solve for x, and we did that. So our x is 50. Okay, so let's check our answer in the last example. So I had log of 2x equal to 2, and I got that my x is 50. When I plug in this 50 into the log, I get log of 2 times 50, which is log of 100, which is a positive number, so this is a valid solution. Okay, so we have another example. This is log of 3x base 3 minus 15 equals 0. So I'm solving for x. The first thing that I have to do is to isolate the log so that then I can isolate the x. So I have minus 15. I'm going to add the 15 on both sides. So plus 15 plus 15. I'm going to get 5 log of 3x base 3 equal 15. And then I'm going to divide both sides by 5, the coefficient here. Divide by 5, divide by 5. I would get, these two would cancel each other. I would get log of 3x base 3, 15 divided by 5 is 3. So right now I have the log isolated on one side of the equation. I want the 3x. I want the x actually. So 3, which is the base, to the power of 3 is going to be equal to this one. So I'm going to write that here. I have 3x, which which is the argument, equal to 3. This 3 is the base to the third power. So I have 3x, 3 cubed is 27, and then divide by 3, I get x equal 9. This is our answer, and we're going to check to make sure we get a positive number for the argument. So if we plug in this one in here, we're going to get 3 times 9, which is 27, and is a positive number, so our answer is right. That works. That is the solution to our equation. I have another example here similar to the last example that I did for you guys to try, so go ahead and pause the video and we'll go over it together. Alright, so I have 15 minus 5 log of 16x base 4 equal to 0. So the first thing that I want to do is to isolate log. I'm going to move the 5 log to the other side, so if I add this to both sides, what I'm going to get is 15 equal to 5 log of 16x base 4. And then I'm going to divide both sides by 5, and I would get 3, 15 divided by 5 is 3, equal to log of 16x base 4. And then I have to change this, rewrite this with exponential form, so that means this 16x is equal to this 4, which is the base, to this third power. So I'm going to write that. I have 16x equal to 4 base to the third power, 4 cubed. So 4 cubed is 64. 16x is equal to 64. So 16x is equal to 64. So my x is equal to 4. And we're going to check to make sure if this 4 gives us a positive value. So if we plug it in back here, we're going to get 16 times 4, which is 64, which is a positive number. So this answer works. Our solution is 4. Alright, here I have another example. Log of x base 4 plus log of x minus 6 base 4 equal to 2. Here, as you can see, I have log of something plus log of something else, and the bases are the same. So by the first property, I'm going to rewrite that as 1 log. So here on the left side of the equation, I'm going to have log of x times x minus 6 equal to 2, and the base is 4. So that is going to be log of x squared, if we distribute this, x squared minus 6x base 4 equal to 2. So now I'm going to rewrite this with exponential form. So this is x squared minus 6x equal to 4, which is the base to the second power. So 4 squared would be 16. And then I'm going to subtract the 16. So let me just write that as 16. And then minus 16 on both sides. I would get x squared minus 6x minus 16 equal to 0. So now I have a quadratic equation equal to 0. So let's factor it out. So I have negative 16 and negative 6. This looks like 8 and 2. So minus 8 because this one is a negative. And then plus 2 here. So negative 8 times 2 gives me negative 16. And then if I add them, I get negative 6. So if this one is equal to 0, I have x equal to 8. This is one answer. And then if that one, the second parenthesis is equal to 0, x equal to negative 2. So I have two possible answers. I'm going to check to see which one works. So if I plug in 8 back here, it's positive, so it works for this one. And then for this one, it's 8 minus 6, which gives me 2. It's also positive, so 8 works. And then for negative 2, I get a negative number here because it's going to be log of negative 2 base 4, which is undefined. And then it doesn't also work for this one because it's negative 2 minus 6, which is negative 8. Same thing, it's negative, it doesn't work. So x equal to 8 is our only answer, and this one doesn't work because this is an extraneous solution. So that's it for this question. Okay, so I have another example here for you to try, and you can use these properties to solve that, and then go over it together. Alright, so it's log of 15 minus 3x base rat 14 minus log of 3x base rat 14 equal to 2. So as you can see, I have two logs with same bases and a minus sign here. So I can rewrite them as one log. This is log of 15 minus 3x divided by this one, 3x, and the base is the same, equal to 2. And then I have a common factor of 3 in this 15 and 3x, so I can rewrite that as, the 15 minus 3x. I can factor out a 3, and then I would get 5 minus x. So I can just write that here. And then as you can see, these two 3's would cancel each other. So I can simplify that and write it as log of 5 minus x divided by x base rat 14 equal to 2. And now I can rewrite this equation with in exponential form. So this one, 5 minus x over x is equal to the base, which is 14, rat 14 squared to the second power. So this one and this one would cancel, so I'm going to have 5 minus x over x equal to 14. And then this 14 is divided by 1, but we don't write that. So if we cross multiply, we get 5 minus x times 1. I don't need to write that. And then 14 times x, 14x. And then we just need to solve for x now. So I'm going to move this x to the other side. Plus x, I would get 5 equal to 15x. And then if we divide both sides by 15, we get that x is 1/3. So we're going to have to check our answer to make sure if we get the right, if we get positive numbers. So in the first one, if I plug in that number, I would get log of 15 minus 3 times 1/3. And this is log of 15, 3 times 1/3 is just 1, minus 1, which is log of 14, which is a positive number. So for this one it works, and then for the second log, which is log of 3x, log of 3 times 1/3, and then I'm going to have log of 1. This is also a positive number, so 1/3 works for both of them, so